Hello, campers. Hope you have been enjoying our camp with all the enthusiasm and curiosity to learn new things. Today, we are going to continue our camping. We might, you might have already set up your tents. Now, it's time to look through the view. So, with this, we are going to start the third session of our Compose camp. I, Soumya Sagar, is going to be your camp master for today's session. So, tighten your seat belts and let's dive into the Compose world. So, before starting out, let us have a quick look over the various topics we are going to cover in today's session. First, we will learn about constraint layouts, which indeed plays a crucial part in developing stable, responsive, and interactive UIs in Jetpack Compose. Then, you will have an insight about the concept of effect handlers and their use to prevent many side effects that could have hampered our application significantly. And then, to put an end to a boring, tiresome static learning of Jetpack Compose, we will finally dive into the world of animation in Jetpack Compose, where you will be learning to various animation libraries and codes that will help in developing quite good animation in your app. You will be also shown designing an animated circular progress bar and an animated drop-down menu, which will clarify your doubts regarding the implementation of animation in Jetpack Compose. After that, the idea of animated splash screen. Yes, not the old static splash screen, but the new Compose animated splash screen will be implanted to your minds. We expect that by the end of this session, you will be capable of developing application which holds animation and designing very cool, balanced, responsive UIs in Jetpack Compose. So, without any further delay, let's begin today's session. Okay, so let's first learn about the designing in our application, the constraint layouts. So basically, constraint layouts are the future of designing cool, extensive, responsive UI for Android application. You will be able to manage various views, constraining them to other views or parents or the side walls of the activity. Those of you who have been using the constraint layout in the XML might know how to use them. Using constraint layout in Compose is also not that hard, but before using the constraint layout, make sure to add this dependency in your Gradle files, as the constraint layout is not by default present in Compose. Moving on to the next slide. Okay, so here I have written a sample piece of code for you. Now let me go through it and explain you the things bit by bit. First, I made the constraint layout function that is by default provided with the Android Compose. Using modifiers, I configured how much space and what background color will our constraint layout possess. After that, the code in the code block, I have initialized various views that our constraint layout will hold, like the logo, which is an image asset, the top bar of the app screen, and the company name, which is a text view indeed. Now, for the individual items, I have given constraints to them programmatically. That's basically how you put constraints to view in Jetpack Compose. Now, you can see there is a property called the constraint as. Constraint as property is basically used to link the nodes of a view to other nodes of other view or to any other parent or to the walls of the screen or your activity. Here, as you can see, there are three important lines that are top.link to parent.top, start.link to parent.start, end.link to parent.end. So that what these three lines actually mean. So the top node of the top side of our view is attached to our parent's top. That is here, our parent is the entire layout covering the entire screen of the device. So this attaches the node to the upper wall of the activity screen. Similarly, the next line states start.link to parent start. What this means is that the left side of the view is attached to the left wall of the screen, and the end or the right part of the view is attached to the right part of the screen. Note that here the start and end are left and right respectively. So after the constraints are put, we set the background color of our app as blue, and then the inside the code block we just simply put the text which should be displayed in our app bar. Here in the second pic, as you can see in our slide, this, the start and end are attached to the start and end of the parent, that is the activity, as I have already mentioned. However, the top view is attached to the app bar's bottom instead of the screen. Now, why is this so? Because when you when the screen sign changes as the device changes, the image can adjust itself as per the app without distorting the entire user interface. The bottom of the image is attached to the text in our app that appears at the bottom. And let me show the remaining code. Yeah. So this is the remaining code of the program. This also has the same configuration as I have mentioned above. Have a look into this and you will definitely understand what it is. Okay, now let's move to the output that this code will generate. Here, as you can see, there are three parts. The first part is a top bar that is constrained to the top, left, and right. Then there is a image constraint to bottom of the app, left, right, and the top of the next to the text that states Google Developer Student Club. And finally, there is a text view that says Google Developer Student Club that is constrained to the bottom, left, and right, and also to the top and also to the bottom of the image bar. So, what did we learn till now? To constrain a view, we can majorly use these four attributes, that is the parent top, parent bottom, parent start, parent end. In the right hand side, you can see a diagrammatic representation of constraints. There are four constraints on the four sides of the view B. Besides, there is a baseline which also exists in order to align various views along the same line so that they're in a straight order. Okay, so before moving on to the concept of effect handlers, I want you to study a sample piece of code. Here, have a look on this. Here there is a function, my function, and within it we have a network calling function and a button which states click me. Note that this is not an actual network calling but a pseudo one. It literally does nothing, but for the use of example, I'm using it. Now, whenever this composable function executes, the function network call is executed and we hit the button and the toast gets displayed. But there is a serious bug which is present here and has been not handled. So can you notice it? Okay. So let me tell it to you. So on every recomposition, there are two tasks that is performed. First is the function that network called, and second, the button is developed when we click a custom toast appears. Now, what is the problem here? Okay. So on firing the button, this thing that, like I have said, occurs. Now, imagine for one network call, it suppose takes 1 minute. And assuming, as the mathematics says, then for n decomposition, it should take n minutes, right? Now, assume that this n has a very greater value, some like a very great value. So, what should we expect? That for such a single operation, we are taking too much amount of time, and which is definitely not an optimal solution, as we are required to just access the network once. So, what we need is a function network call must be called once, no matter how many recomposition have took place already. So, what should we do exactly to make it run exactly once in any other recomposition? So, the answer lies here in the side effects. So side effects are basically any task which is not the actual part of the execution or need to be run once. Side effects are undesirable because they can potentially change the state of the app outside the scope of composable. This basically means that the composable function might not behave the exact same way when called multiple times. Since a composable function can be executed multiple times or can skip execution altogether, mutating or relying on the global state in composable function can lead to unforeseen errors or bugs. Hence, relying on side effects is not an recommended approach. So let me show you the altered code which could definitely solve our problem. Here, as you can see in the code snippet, the function is now in the scope of side effect provided by the Android. Now what happens is that on every recomposition, the function just calls once, that is in the initial recomposition. And on any other recomposition, this piece of code does not get executed. So the network established is just once. And hence we save time and memory. Moving on to the next type of effect, disposable effect. Okay, so sometimes we need an actual cleanup of memory or the caches after a recomposition. For example, when you acquire resources and now you want to get it clean, when your view is no more available, you are supposed to release that resource, and this will help the app clean up any dangling pointer errors. So we cannot do this using the side effects. So we have to think of some better approach. So in order to achieve something like this, we can use the disposable effect. The code under the disposable effect block makes sure that the resource gets cleaned up before moving on to the next piece of code. Now, I will make you understand this concept by giving you an example. Okay, so here we have a function called my compose. It has a backpress dispatcher as a parameter. Uh, Now just keep in mind for now that the backpress dispatcher is like a container that stores event when we hit the back button in our device. Okay, so don't create so much fuss in your mind about this backpress dispatcher. Next, we define a variable callback. So what this does is that it remembers the state of the backpress. We just pass an object of the backpress callback so that using this callback object or instance, we can dispose the data. This might be a little bit confusing, but just think it as a variable callback which holds the backpress event basically. Okay. Next, we have a disposable effect which has a key parameter. Now this key is important because this stores the backpress dispatcher, that is the event of going back. Now we just add a callback we created above. Then inside the on dispose code block, which is provided by default in for using the dispose block effect, we remove the callback here. Hence, the object of the callback that is used to do something, as you can see in the above code, the on press callback function. So here at this part of the block inside the on dispose callback dot remove is called. So what this does is it basically erases the callback from the memory, that is basically erase all the data associated with that callback. And then there is a basic button that says click me. That is not the relevant part, but the main part was a dispose effect. So I hope that it made some sense to you, and practice it and you will definitely go good with it. So the launched effect. Now, this is another type of effect. Basically, we use this scope whenever we work with coroutines or need to run something inside the coroutine scope. By the way, those of you who don't know what is coroutine, so it is basically a part of multi-threading. Your app runs on the main thread by default, and if you want to run it on a different thread, you have to set a coroutine. This releases the load on the main thread as there are more than one thread now. For now, just remember it is something that you can do parallelly at the same time. Codes in multiple coroutines run parallelly whenever the main thread is run, or basically speaking that whenever the app is run, all the coroutines run simultaneously. Okay, so coming back to the main topic, let's understand what is the launched effect by a simple example. Here, have a look on this code snippet. We have a scaffold state to display the snack bar. Then we have a coroutine scope within which the snack bar must run as a suspend function. For the suspend function is basically the function that runs in a coroutine. Just remember this. Now there is a counter present which increases when we hit the button. So here the condition is whenever we hit n times, where n is a multiple of 5, then a snack bar pops up. So let me show it to you. Here on the left screen, as you can see, the left emulator. That is what I want to show you. So whenever you click, the counter increases and it is shows divisible by 5 and so on. However, there is a small bug. Can we find it? Just observe the left part, not the right part. Well, if you haven't observed, then let me tell you that observe the animation, the popping out of the snack bar. Whenever we hit 5, 10, or 15, it pops up. But don't you think that the animation is basically getting queued up? So whenever we are hitting so long till like 20, 25 or any other, this animation gets queued up, and even after the clicking stops, the queued animation gets played as per its time limit. Now this is basically a very bad user experience, and this is not that an Android application developer would want its user to have. For now, what we should do is whenever that 5 appears, like the multiple of the 5, then it should get displayed, the snack bar, and for any other number, it should just simply cancel out that snack bar immediately. So how can we achieve this effect? So the answer lies in the launched effect block that we discussed here. So now see this piece of code. Now this has the use of launched effect. Now this is basically the same code as mentioned earlier. What differentiates it from the previous code is that there is a block of launched code effect with a key called the scaffold state. So basically this holds the state of the snack bar. And what is the possible output that you assume it will produce? Here, see the right hand side. Only when the 5 appears, the snack bar pops up, and immediately when the next counter hits and 6 comes, the snack bar gets cancelled out. Observe it very carefully. And now compare the left hand side of the emulator with the right hand side of the emulator, and you will surely find a difference. So I hope this made some sense to you. Okay, campus. Finally, after a very long, tiring journey of static knowledge of Jetpack Compose, we are here at the animations. So, refresh your mind as this is something exciting you will learn about in the upcoming slides. So, without any further delay, let's begin the topic of animations and Jetpack Compose. Jetpack Compose provides a various number of animations, which helps in designing various kinds of effects that are dynamic in nature. It makes the UI looks better and interactive. Animation APIs also exist, which helps in executing different tasks in Jetpack Compose. However, we wouldn't be discussing the API use. We'll be just making the basic animations from scratch. Now, enough of the definition part. Now, let us first go to the example. Okay. So before moving on to the example that I'm going to show you, let me tell you, let me make you familiarize with a concept of animation DP state. So this property is basically used to store the state of a dimension of a view while animation. So think it like a mutable state that exists while the animation is in progress. So this basically stores the information about the dimension. Okay, so this is the example. Now, this part does not use the animation. We have just put a simple code. We have made use of a box. We have adjusted its size and background color and made the content centered. Now, on a button click, what happens is the size state, that is the initially it is set to 200 dp. Now that increases by 50 dp. However, the thing is that it increases very rapidly. Like you can see in the output that whenever the increase size button is hit, it increases very rapidly. So now here is a code alteration. Now we are using the animation state. You can see that the size state is given the 200 dp initially, but then here we are using a property size, val size by animate dp state, target value equals to size state. So what this does is now it instantiates the size with the size state that is initially given 200 dp. So then we pass it to the box container. So what happens now is that the box changes its dimension, but it actually animates and gets bigger in size. You can see in the output right side of the screen, the animation is visible. You can see the difference here and here. Here, the animation was quite speed, but here, as you can see, there is a slight bit animation, and you can see the progress of the animation within the different dimensions that it is accessing. Okay, so let's coin a new terminology, that is the animation spec. This defines the type of animation to be performed on the view, like the path of the animation, whether it should go round and round or like a spring or a circle. Such properties are defined using animation spec. Now, earlier what you used to do was we just defined a basic animation state, but we need to now define an actual path because we don't want just a single type of animation. So let's move on to the different type of animation that is given in our animation spec. Here, these are two basic examples that we'll be discussing. The left hand side is a tween animation. As you can see, it's the box slowly pops up. And here on the right hand side, the Android logo, as you can see, it produces a kind of spring effect. So we will be discussing this too. And besides that, we will also have some bonus content for you. So hold tight. Okay. So let's first discuss about the tween animation. So this is a basic kind of animation spec you can use in your application. Now, this piece of code, you can use it in the box animator you saw earlier in that animation DP state, that you can just put a comma and then write this piece of code. And what this will now produce is that you can see the animation is moving smoother, like quite different from the earlier state. So this is a basic type of animation. Moving on to the next type of animation, that is the spring animation. Similarly to now, this is another type of animation. As the name says, the animation is like a spring type. You can see the compressions and the expansions here on the left side. On every button click, the size increases and is associated with the spring animation. The code is given on the right hand side. You can just simply put this piece of code like the tween animation inside the animate DP state and pass it as a parameter. So this is the animation spec parameter. Okay, now this is the bonus content we are speaking of. This is one kind of animation that is very useful. This is called the keyframe animation and is based on individual frames. As you can see, the animation gets placed here frame by frame. You set the duration and the size state multiplied with the frame number. So basically the frame number here is a floating literal. You can imagine it like suppose the total screen will take the value of 3.0f. So at 1.5 value, that is basically the half of the screen, the animation plate is linear easing in, and at 2.0f you can play some different animation. Here I have kept that same animation, so you wouldn't be noticing much of a difference, but you can play with it and try a different animation and you will observe some different animation at different frames. So this is surely that will help you play with the animation part nicely. Okay, and this is another bonus content for you, the infinite type of animation. The infinite type of animation is an animation that gets played infinitely, of course. Here I have written a piece of code where the color changes from one color to another and from another to the earlier one, and this process repeats itself infinitely. Um, Here first I made a launched effect, and inside it I made all the necessary statement because I just want it to execute just once in the recomposition. Then I have used a variable called infinite transition as set and set it to remember infinite transition. Now we set the colors The initial value is red and the final is green. We define a basic animation spec. Here, that spec is infinite repeatable. So, as the word suggests, that it will be playing infinitely and the path will be repeated. And then what this does is that first it changes the color from red to green and then back from green to red. And then this happens, of course, infinitely. We also have added a small button down like all previous snippets. So when you hit the button, the dimension increases, and at the same time, the color infinitely changes from one shade to another. So here's the output. Here, as you can see, the red color changes to green and green to red, and this process repeats itself. And whenever you hit the increase size, the size of the box just gets altered and increases. Okay, so enough of the animation example. So now let me show you some basic animation techniques that you can use. So let me show you an animated circular bar using what we have learned so far. This will just use enough animation and some basic implementation. So focus properly. This is the code snippet I have prepared for you. Yeah. So let's decode it line by line. The first parameter is the function declaration circular progress bar. We pass various attributes to it as parameter. The first is percentage, that basically means the circumference to which it should load. For example, 0.7f means that 70% of a complete circle. The number parameter is the number which is displayed on the screen and suggests the amount of loading, like 25%, 65%, 75%, whatever. Then there is a font size, of course, a radius of the circle, the color and stroke of the pen with which we will be making the circular cue, and there is animation duration and of course a delay. So as usual, we define an initial state by remember, which is false. Then we make a variable cur percentage, that is CORPER, and use the property animate float as state. So mark that earlier we used to use animate DP, that animate float as DP, but here we are using the state. So we are basically transitioning between the states now. We have a target value and it is equal to the percentage if animation is played. The animation played boolean value tells that. And if false, then it is 0f. So that is the basic beginning of the stage where it is invisible. Then we put a basic tween animation with a parameter. So those of you who had a doubt how to use tween animation, you can see here. It is passed inside the animated float as state as a parameter. Then we have a launched effect here in the right hand side, you see. We have a launched effect and we just put a basic animation played true inside it. So whenever the recomposition happens, it just gets played to true. We then define a box inside which our circular bar will be present. Now to make the circular bar, we use a tool provided by the Android that is called the canvas. So canvas is something that allows you to draw out different shapes in Android. So we just define the color, the pen cap and the stroke width, and we just use a simple draw arc function. After that, we also add a text that represents the number to which the circular loader loads up. Inside the text, you can see the curve per value into number. So this is some basic mathematics to convert the floating integral of the circumference value to an integral value that will be displayed on the screen. Now, let's see what this piece of code will generate in the emulator. Here, as you can see, there is a circular bar which is green in color, and it loads up to 70% that is given, because here, as you can see, we have initialized it to 70. It's actually 80%, but I just mentioned it wrong. It is 80%. Yeah. Now, as you can see, the animation is not smooth because it is emulator. So we hope you adjust with it. Okay, so let's create something new that is called the animated drop down menu. So you must know what is a drop down, like you hit an arrow button and some content gets displayed. So this is what we are gonna do it, but this time it will be a more of an animated style. So first here we just made a simple composable function drop down. We pass the string that should be appeared, a modifier, a open function that will say whether it is open or closed, and a content like what should be present inside that drop down stuff. And first we initialize the is open by a open state. Then we have an alpha value and animate float as dp. So if you look at this line, what this means is that if is open is true, then it will be 1f. That is, it will be completely visible. And if it is not open, like is open is false, then it will be 0f. That means that it is absolutely invisible. And we have also put a animation spec of tween, that too of 300 milliseconds, like zero 0.3 seconds exact. And then we have a rotate X parameter because what we want is something like this effect. Let me show you. You can see the bar is actually moving on an axis from 0 to 90 degrees, like it is making a complete 90-degree rotation. So this is kind of a 3D transform. So we are making a rotate X parameter here, and we are again giving it 0 if opens and 90 if closed. So what this means is that whenever it is true, it is closed, that is 0, and when it opens, then it will give a 90-degree rotation. And similarly, we have added a basic tween animation to it. So now let's design the actual content, that this hello world, the arrow one, and the green part. So let's design that. First, there is a column, and then there is a row where we have placed this arrangement as space between. Here you can see hello world and the arrow have space between them. So this is that parameter. Then we have made them vertically arranged and used the modifier to fill the entire width. We have a text and we have set the color and the font size. And then we have an icon. The icon is basically the arrow you can see here on the right hand side, in the hello world column. Okay. So what we have done here is that we have used the basic icon that is given in the compose, and we have added a content description, open or close, the drop down, and we have used a tint color of white, and then using the modifier we have made it clickable. So what happens is whenever you hit the click, the is open gets negated, like if it is true then it will get false, and if it is false it will get true. And here we have used a scale property 1f. Now this line may be confusing, so let me give you what this does actually. So here as you can see, when we hit the button, it gets shows up the content, and the arrow key, if you close observe it gets mirrored. So this is what this line is doing. So minus 1f is giving the down arrow key, and whenever it is hit, it gets converted to its negation, that is 1f. So it is basically getting mirrored. Okay. Now then we have added a basic spacing using the spacer, and then we have designed the box, that is the content, this green part you can see. So we have added a fill max width and graphics layer. This is something new to you. So what graphics layer does is it helps you in designing a 3D transformation. Like you can see, this is a 3D transformation. So graphic designing helps you in generating a 3D transformation. So here you can see the value is from 0.5f to 5f, and the rotation x value, we have initially given the rotate x parameter here. So we are just passing it here. So this is the piece of code, and as you can see, this is the output. As you can see, whenever we are hitting it, it is showing, and you can see some 3D appearance of it. The green box appears like as if it is rotating along the axis. And one more thing here, the transform origin is basically the axis. Initially, if we were seen that the axis will be present in the mid of this box, and we wouldn't want it, because if you closely observe that the axis is actually present at the top of the bar, and around it, it is moving. So that is why we have moved the axis to 50% of the above the view, because initially it is present in the middle, so 50% above means it will place it exactly at the top of the content. So using that, we can now rotate it along that axis. As you can see here, the output is in the emulator. Okay, so let's move ahead to splash screens. Now, those of you who don't know what is splash screen, so splash screen is basically a welcome screen that appears on the app whenever the user first interacts with the app. This is basically the welcome screen that displays that may display some company logo or a hello world type thing. And this basically gives the first impression on the user how the app will look and gives basically the impression. Okay. So this is the basic composable function. Like this is the very basic splashing you can use just a message card, and it will say hello Android. Now let me just give some animation because this is the animation part of the compose exactly, right? So let's decorate it a little bit. Yeah. So I wouldn't tell you to look into the navigation part exactly because this is something that you will be taught in the next session. Just for now, think that the navigation control is the object, and there you have two screens. You can see the composable main screen and the composable splash screen. So these are basically two composable functions. You can assume it as two screens, and using the navigation control, you can just uh, toggle between any of these. So that is what the navigation controller is all about. So the main part is the splash screen code in the right part. Here you can see we have just initially declared a scale because uh, okay, let me show you first the animation part. Here you can see this is a simple drawable of me, of course. Like that doesn't look exactly me, but okay. So what this happens is you can see the avatar is moving in like a zoom in effect. So it is basically increasing its size. So initially the scale parameter is 0f. So that is first the avatar appears like a single dot. Then we have made it into the launch effect because what we want is that this entire effect occurs once. As you can see, it occurs once and then directs it to the main screen. So for that we have put it in the launch effect. Now we have used the scale now to increase its size to 40% of the initial. As you can see here, first it is 0 and then it increases to 40%. Now if you have been made it to 1f, then this emoji would have completely taken up the screen. So then we have put a basic animation tween one, and here is a concept of interpolar. So interpolar is basically a mathematical stuff, and I wouldn't want you to look exactly into it. Just for now, know that it helps to transition between the animation states in a geometrical manner. So here, as you can see, it pops up from the screen like it is coming out of the screen. So this effect is achieved using the interpolar. Okay. And then we have a delay of 3 milliseconds. Like you can see, after the animation is played, one, two, three, and then the main screen appears. So then using the navigation control, we are just indenting it and putting the main screen up. Then the next part is the designing of the logo. Now we have just simply put the box, aligned it to the center, fill the max size, and we have used the painter, which I have already discussed earlier. That if you don't know what is painter, so painter is basically a tool using which you can access the drawables or any image assets in your game. Okay. Now I have adjusted it manually to height of 500 dp, height and width both, and content description is basically a logo. So this is the animation. As you can see, first the splash screen appears, then it directs to the main screen. Okay, now it is time for you to try out yourself. Like I have taught you enough of what you need to know, all the concepts like the animations, the kind of animations, and how to use it up. So now it is your job to perform all the tedious tasks yourself and try it out so that you can get a hold of it. Because now on, I expect that you would be like not exactly completely comfortable, but a little bit comfortable. So you can just play with the animations you have and then just simply generate awesome animations and make your app look quite interactive to the user. Besides, you can also use the constraint layout also because that is really important if you're going for responsive UIs. And the effect handlers, whenever I have already explained you what are the scenarios you can use it. So try it out yourself and experiment it. With this, I would like to conclude. Have fun encouraging your community and becoming Android developers while happy camping. Well, that was all from my side. So anyone can leave it. leave the meet because the session has already ended. And yeah, try it, the application what I've